Hi everyone, welcome back to our next session of Strands. This is the part 2, so if you haven't seen the part 1, just give it a quick view. It's a very short video and you're gonna love it, and after that you can come back to this video to see some of the core concepts which you're gonna be discussing in this video. Now, to give an overview what we're gonna be covering in this video, here's a section which you're gonna be focusing on. These are some of the really important concepts when you work with any agent, especially when you work with strands. You should be aware of those concepts. When you design your system for production level, you're gonna be highly dependent on these concepts and using each one of them. If you are aware of some concepts, I'm going to be going in this flow, what you see here. So you can skip the video and try to focus on the part which require basically your attention or you need help. Before we start, and I'm going to show you some code. Let me just give you a highlight what each concept is and what I'm going to be covering. In agent loop, basically it's a theoretical concept. I'm not going to go jump into the code, but I'm going to show you what agent loop is and how agent basically strands handle its reasoning part behind us before it respond to the end user. The second concept is system prompt. System prompt think is like a programming language for agents. Now this is how you restrict or set guardrails for the agent, define its role, what it's going to be responsible for it, and what thing is going to be doing for you. So this is a really important concept. Just pay attention to this one and how prompts are important and prompts can be used. Now, the third concept is session management. Now, if you have used some of the tools like ChatGPT or Gemini, you have seen how it know or it is aware of your past conversation and respond accordingly. So in this we're gonna see how we can achieve that with the strands and how we can retain the session, although with the completely new request, and how it can pull out from the past conversation. Bedrock model is something where we're going to see how we assign a model to our agents and some of the important arguments which is required for that. The next concept is max token. This is really important if you are designing a system for high availability and require a lot of traffic. So you need to be considerate about your token usage. And in this section, we're going to cover and we're going to see how token usage, or basically how max token convert to a number of requests it can serve. The other concept which is really important is very closely related to the token usage is conversation manager. Is basically when your conversation grows really long, we're gonna see what are the different approaches we can use to narrow down or reduce that conversation manager, so our token usage can be reduced and availability can be increased. The last concept we're going to see how guardrails are set in AWS and how we can pass to our agent. So without wasting our time, let's jump into code and see how each these concepts are and how you're going to use those. Before the code, let me go over agent loop, what agent loop is. For this, I'm going to be going over one of the documentation which is provided by the strands, and here if you go to the agent loop, it defines what agent loop is for you. So when you before we go to the agent loop, let's understand the difference between agent and any other API call which we make. Now when we make a single shot request to an API call, it just take that request and give you an response to it. Agents are a little different. Agents are more of goal oriented. You assign them a goal and their task is to find the tools available for them, reason or get the output from the tools, reason them, and keep this loop running until unless they achieve their goal. So that's what agentic loop does for us, and that is called agent loop. It comes strands do it out of the box for you. You don't have to do it. You don't have to implement any code, but to give you a perspective, here's a simple code which is from query processing. If you go to MCP client, now if you see here, for query processing, what are different things we did? We make a call to get all the tools, and we get their tools response. Based on the tool response, we see is our goal is met, and then we make another call. So there are multiple API backend calls are happening, and until this goal is met. So all this code is basically taken care by strands, and we don't have to define those. But the thing which we need to define is set the goal for an agent, which take us to our next part, which is let's go to system prompt. Now, if you see here, it's a very simple agent. I haven't given anything here, and if I run, it will be able to respond to it. But this agent does not have any role assigned to it at this point. And what does it mean? This agent is just single shot agent. You give the request to it, it's gonna respond, and that's it. It's no different than a simple calling a Bedrock API call. Now, what basically system prompt means? System prompt is in one argument you can define here. So let me give a simple role here. I have a simple prompt. I'll bring it here, and now this is a simple role. So here I have I give it a role as a retailer who need to consider that whenever the customer comes, he need to give a chocolate if it is greater than 10. So it's a simple calculation it needs to do based on the request, and we can see how it handles here. So let's say instead of hi, let's say I can say I have $20, can I have chocolate? So now it should know that because the request is mentioning that $20, it's not accurate, but like it says, okay, which is greater than $10, I can provide you. So it does understand its role, that what it's supposed to do, and it does understand what user is trying to ask and giving a response for that. So it's a very simple example of system prompt, how you can configure it, and how you can use it. So in system prompt, we're going to use it more now when we go to the max tokens and other, but I'm going to leave it here for now and come back again to system prompts and how we can set another guardrails, soft guardrails, which are called using system prompts. Now the next topic is session management. Now if you see here, right, I asked that, okay, I do have $20 and can I have chocolate? It say yes, I can have it, but will it remember if I ask do I have enough budget left for chocolate? So in this case, if you see here, right, I'm trying to further the conversation what I did earlier here. Now it's new request, completely new request. So if you see here, I'll be happy to determine if you have enough budget for chocolate. However, I need a bit more information. So it does not remember what was there before, and it completely starts from the scratch. So each request is treated independently. Now to maintain that connection between our past and this request, what is important concept is called session management. Now let me go to the documentation for there. We're just going to use those. And if you see, there are two type of session management Strands provide. One is file. What it means is like the messages are saved in memory. So if you are running a compute which is EC2 instance or long running compute, you can use file manager. The other option you have is S3 session manager. So if let's say your compute is on Lambda, which is each request is treated completely independent, have no idea, then you can pull out from your session from session manager, S3 session manager, and that is much better option there. So in our case, let's give an example for file session manager. Let's see how it works. So I'm just gonna copy this part and go back to the code again. Let's see. Now here, if you see, it requires a path where it needs to be saved, and by default it uses a temporary path, but I want to show you the messages, so I'm just going to use the path where it is. So I'm just going to copy this, and now it's going to create a session folder if not, and then it's going to save here. So I do have a session folder. What I can do, I can just delete this to show you the example. Now let's go back to our question, which was I have $20. Can I have my spelling sucks. All right. All right. So now we go back to our previous conversation and then let's see what happens now. So it did something. Yes, absolutely. You have $10, and I don't think so. It just hallucinated a lot of stuff here, and that's where our basically system prompts come into the picture. But we're not gonna go into that right now. But this is what you can see, right? I wanted it to be just giving this, but it just come up with all of its own hallucination here. Which is good, but it does not work in an application which is, let's say, you are pulling your data from database and just giving some random information. So I see this. Now what I'm gonna do, I'm gonna ask the same question again. Do I have enough budget for one more? So in this case, it should remember that I have used $20 before earlier and 10 was one. So let's say what it come up with. Actually it didn't give me, oh okay, my bad, sorry. So this is actually a very good example here. So the reason why it didn't give, because we didn't even initialize our agent with session manager. So although we created here, but it was never passed here. So let me do that, sorry for that. So it's a session manager and we just assigned our session manager. So now it should maintain those session there. So let's see. And what we're gonna do now, we're gonna ask, do I have enough budget? You can also go and see in a session, now it started to record all the messages. From your $20 after buying the first chocolate, I need to calculate your remaining budget, then I can rely. So basically it does remember that I have $20. It's just having a hard time to understand what is each chocolate means. So the good part is the conversation manager is managing the history it requires. The previous conversation is this one. I can say to have one more chocolate, and I can go further into it, say okay, each chocolate is for $10. Now can I have? Although the ideal case should be, it should be identifying it from there, but apparently it's not. So it is managing that session manager, but it's just not giving the expected output. It's not intelligent enough at this point. Another thing you can see each of these messages, what we talked about is managed here in a conversation. We say so it does save all our messages and basically respond based on those. So if you want to maintain all your chat history conversation, this is how we can do it, which is file session manager. And now our next important question is Bedrock models. Now it really depends upon what model you want to use. So let's say model. Now it allows you the flexibility to use any model here, so which is, and let's import from strands dot model import. Okay, so now we have seen I think so it is models. So okay, now we have Bedrock model, and then what it accepts is like basically your ID of model ID. The other thing which I wanted to show you is temperature, which basically define how accurate or how creative you want your model to be. So if you are designing a system, let's say on a real-time production system, which is, let's say, on top of your database, or you have your application and you want it to be as accurate as possible, lower down the temperature would be a preferable approach. And if you are designing a system, let's say, which can an agent which writes poem or songs, more creative would be something where you can go by increasing the temperature there. And the last is max token, which I think so we should see here, very important. And for example, I'm going to give you 200 here, for example, and let's see what the difference will be. I have a model ID which I'm going to be using is Claude 3.7. You can use any one which you have access at this point. Now, we have already seen the temperature, how it affects your response. Um, Focus would be on this max token thing in this case in the model. And before we go there, we see how we can define basically model assign. Similarly, how we have passed an argument for session manager, we're going to be using a model here. So model would be the model which we have defined above, and that's it. So once you have this information, now it's going to be using the model which you have defined above, and these informations are saved there. So we're going to be asking the same question. Let's say just extend this conversation to understand better. So say each one is for $10. Exactly, one chocolate. So basically it remember the conversation, it extended that and give the response. That's good. But here what I wanted to show you something else, which is max token. Now max token, if you've seen, I have 200 is able to respond. Now let's say you have reduced to 20, and let's see what happens. So yeah, that's what one of the things I wanted to show you. So normally in API endpoints, when you have worked with, you have seen when you hit the max token, it give you truncated response, so it never fails for you. But Strands does not handle it in that way. Instead of that, it raises an exception which is called max token exception. Now if I again increase it to 200, it is able to return me the response, because now the output size is basically above 200 or under 200 at this point. Actually it is max token for 200 also reached. Let's reach 500. Let's see what happens. So now the output size is under that limit, and that's what we can now it's able to respond it. Now I wanted to show you another thing which I have seen it worked in the past. Is, let's say I'm gonna reduce it further, the token. So let's say I reduce it to 100, and so now I have reduced it to 100, and what I'm gonna do, I'm gonna basically add another prompt. This is called soft guardrails basically, and that's what I was telling you earlier, that a system prompt is something which is really important, and think as like a programming language for LLM models. Now you see I have added XML tags. Now depend upon the which model you are using, it might not be applicable, but if you are using with the Claude Anthropic models, they understand after 3.7, they really understand very well about XML tags, and you can define different section into different tags. So for example, this one is like a response limit I have defined. Similarly, if you are defining a security where it says I don't want to reveal any internal information, then you can provide them inside a security tags, and I have seen them work very well when you divide them into different sections, and model understand it better. So ideally it should throw that max token, because we have seen it earlier. Now when we run it, try to reduce the size. So if you see, the responses are very less smaller now as compared to what we were getting before, and it is trying to prevent that max token exception where. But again, this is not always 100%. This works sometimes, but this is one way of setting this your basically setting the soft guardrails. Uh, and now, before we jump into the next section, I want to show you simple calculation which actually help you understand how max token works and why they are really important. Now, max token is something which is a limit set by you, but at the same time, this limit is really important because any token, any model you use, especially when we talk about Bedrock, you have a limitation. For example, the limit with Claude and I know Claude Sonnet 4.0 as well is 200, basically 200k tokens per minute. Now every minute they are refilled, but you have that limit. Now when we see this max token, so we are telling, let's say it is 200, and so we are telling our agent that the output response should be not more than 200. Now this the token what basically your agent reserve is more not just 200, but it the token also include your input plus your max token. And if you see the calculation which is being provided with the Bedrock, you're going to notice that the higher models, which is like Claude 3.7 and all, they have like the output is multiplied by 5. So each token is multiplied by 5 there. And just to give you a simple calculation here, so if you are using, let's say 200 tokens multiplied by 5 input tokens, so you also have a system and a context which is being passed. If you are not cached, but still you are passing there. So let's assume you are using 2000 tokens for each request. So what it does basically, it just takes that 2000 tokens whenever the request comes, no matter what the response size is, it's going to reserve it for you. So if you see 2000 tokens for each request, what it does mean is like you can only serve 100 requests concurrently. So imagine you are designing a system, you can only serve 100 users at one point. So the more higher you go with the max token, the more limitation you are setting it up for yourself. So there are multiple approaches which you can use, like you can have a model fallback. Like once you hit this request in a minute, you're gonna have throttling exception. So there's a multiple ways you can handle it. Like you can have like a fallback mechanism where you have multiple models lined up, and if in one model you got error, let's say 3.7, you switch to 4.0, or you switch to 3.5, and your token bucket is refreshed for them, because it's model based, not the account based. So you are not bound to that specific model like account. So you still have a option to switch to different models. So that's why I was saying, like when you set this max token and how the limitations are. So setting up the higher can impact your availability, how many requests you can serve. So you have to be really considerate, like you have to come up with a solution how optimum you can design your system there. Now let's say when we have seen this part, let's go to next, conversation manager. Now as I was defining explaining you earlier, the max token is not the token it reserve is not just the token what you have set here. It also basically take into consideration of your context and how big your context window is basically. So for that, what we're gonna do, we're gonna see how we can limit the context window. Now there are multiple ways for it. So let's say if I go to agent again, and this is a conversation management, there's a multiple ways. So by default it use sliding window, but there are different options. So let's say if you don't want your context to be shrinked or summarized, you can use null conversation manager. There is a sliding conversation manager which we're going to be using here. What it does basically, the concept here is we are thinking that the previous past conversation are not as important as the current one. So we can slide that window and retain only the current conversations what we have. So for example, let's say if I use this here, and give let's say a size of 5. What it's gonna do, it gonna conversation manager equals to conversation manager what we have defined there, and then give this, And let's say I want to print, instead of this, agent dot window size. I think so there is measure the window size. Now this is something which you can see what is the window size for yourself. So for example, if I'm going to run this, and I did not print it for me, but let's see, I have, what did it, let's see, where did it go? I'm gonna see. All right, so it did print somewhere, I just don't see. Okay, so sorry, my bad. So it did print this window size here, which is 5. It's just in the same line, so my bad, it's just really confusing. Okay, so you see here, it is already only passing 5 conversation, or top 5, last 5 conversation to the agent to get the response for these responses. So you can, based on your basically agent, how your agent responding, does it require a past conversation or not, you can set this conversation manager. But this is really important to basically keep in track your max token usage. So monitoring your max token and reducing the size of your conversation manager will help you to manage or increase availability of your agent. Now the last section is AWS Guardrail. In the Guardrail is something which is model specific, so you don't pass on an agent. Basically, instead of that, you set up on Guardrail on your model level. So each model have you can pass the Guardrail ID and Guardrail basically version ID. I don't know if it is Guardrail version. Yes. Now Guardrail version is either 1, 2, 3, 4. There is no specific IDs for that. And to set the guardrail, how you can get this ID is basically you need to go into your. Now for setting your guardrail, you need to go to the Bedrock. And in Bedrock on the left side, you can see there's under build, you have a guardrails. Now once you have guardrail, I haven't set up anything, and I'm gonna set up with you here. So you're gonna go and create hit guardrail, give any name. I'm just gonna give demo here, and these are the once it is blocked, what you want it to say. So it's optional, and you can give whatever the message you want to print there. Now some of the categories which is saying, let's say harmful categories, you can say hate speech, what you need to set, what is the threshold. Now be careful when you set some every high, like sometimes agent also blocks some of the valid requests, so you need to play around with these and see what is the best fit for your application. In this case, I'm just gonna go for directly next, but like just check it out when you are setting your guardrails. One important thing is this is prompt attack. Now what is prompt attacks is something, let's say you have internal system which you are trying to manage your application through LLM, and a user can write a prompt to get certain information which should not be available to the end user. For example, let's say it can ask how you are managing your password, and you have a tool which says okay, set password, or secret credentials, where credentials are saved, what is the ARN. So those details, it can ask anything about your tools and your functionality. So those other things can be blocked by using those prompt injection. And any topic you don't want your agent to respond, any sensitive information, PII, all those kind of things you can set with the guardrails. Just gonna set it up here, and it's a simple guardrail. Let's see, once you have set it up guardrail, you're gonna get this ID. And if you see here, I don't have a version at this point. Now this is something which will be required when you are working with guardrail. And so what you need to do, you need to go to this working draft, click on that, and you can say create version. Now just click test here. Now if you see here, I don't have any information about the version ID, although it says version ID, but what it means is basically you need to give one here. If it will be version 2, you give 2, and go on similarly for the others. So I'm just gonna give one here, and then same like 2 and 3. Now this is pretty much it. You're gonna set it up. So let's rewind and see what we have covered in this demo. The major thing which we covered, we see what agent loop is, we see the system prompts, how we can define system prompts and in your agent, and what is a role of our XML tags. Session management is something to maintain your conversation history even when you're working in a serverless environment, or when you're working on any compute which can manage your conversation in memory. We have seen defining a Bedrock model, what are the different arguments and what are the importance. We have seen max token, how it impact your availability. Similarly, conversation manager, how you can shrink your conversation to maximize the usage of your available tokens. And the last, how you can set your guardrails. So in case if you have any question on these, just comment down below and I'll get back to you. And hope you enjoyed this video, and I'll see you soon, guys. The next topic I'm thinking about for multi-agent approach, but for that I think this is something really important we understand it before we move there. So thank you so much. See you next time.